Okay, so these notes, we're going to go over lots of theorems, other theorems about triangles. They're already typed up, so you don't have to do very much writing, which is really nice because there's lots of theorems we're just going to whip out really fast. And most of them are pretty straightforward, which is the nice thing. Okay, so the first theorem is the triangle inequality theorem. The triangle inequality theorem says the sum. Susanna, what does the word sum bring up in your head? Sum. What mathematical operation do we think of when we see sum? This is for Susanna. Thank you. Addition. Yeah. So we're going to be adding. The lengths of any two sides of a triangle. And that will always be greater than the length of the third side. Okay? So here's a picture of a triangle. It would be great if you put your glasses either on your face or down. Thank you. A plus B, if you add those two, doesn't equal C. It will be greater than C. Or you can pick any other two. Say B plus C. That sum will also be greater than A. Or you can pick another two and add up C plus A, and that will be greater than B. This works for any triangle. Add up two of the sides, and their sum is always greater than the third side. Okay, we're going to be using pretty much every example we go through today. We'll have matching examples on your homework. Hint, hint, hint. Every example we do today, this is why you probably should pay attention, has a matching example on the homework. Okay, so our first two examples, once we get to the example section, deals with this theorem, triangle inequality theorem. Next theorem. If one side of the triangle is longer than another side, then the angle opposite is also longer or larger. So, if you look at this triangle, it says x less than y less than z. This is sign language for x. Looking at me? This is sign language for x. This is y. This is z. So I would like you to show me, based off of how this is written, x, y, or z, which one is greater? X, y, or z? X, y, z. Which one's greater? X, y, or z? Because there's inequality symbols. If you understand those inequality symbols, you should know which one is greater. X, like a Captain Hook, X, Y, or Z. Carlos Garcia, Puebla, I don't see you guys responding. Tristan? X, Y, or Z. Based off the inequality symbols, and you remember alligator eats the biggest one. Alligator eats the biggest one, so it would have to be Z. Okay, which tells you which one's the smallest. Show me the smallest. Alligator doesn't eat the small one. Yeah, Captain Hook finger, X. Alright, so this theorem tells us if Z is the largest, if Z is big, the side across from Z, would you agree that this side is across from Z? On the opposite side of the triangle, if Z is the largest angle, then the side across from it will be the longest side. If we chose the smallest angle, say angle X, I'll do angle X with the dotted because I can't change the color if I'm in the Word document. Angle X is the smallest angle, so the side across from the smallest angle would be the smallest side. Smallest. Which makes sense, because watch my hands. Everyone look up this way, please. Put the reading book away, please. Okay, right now with my arms, am I making a big angle or a small angle? Small, and how close are my fingertips? Pretty close, together. So opposite of the vertex, my body is the vertex, it makes a really small segment. But if I make a large angle, how close are my fingertips? Really far away. So the larger the angle creates a longer segment. Okay, so large angle, across from it is the longest side. Smallest angle, across from it is the smallest side. We'll have examples, we'll practice these. We're just going to run through the theorems and then we'll practice them. Next theorem, mid-segment theorem. Mid-segment. The segment connecting the midpoints. Midpoints is a vocabulary word we've talked about. Midpoints. Gerardo, can you define or explain for us what a midpoint is? Yeah, so it's the point in the middle, right? Okay, and so I have A to D. If you read further on, it tells you A to B. If you read on, it tells you D is a midpoint. And then we also see these red slash marks. Okay, what do these red slash marks mean, Alejandra? These two matching red slash marks. It's a C word. It means these two segments are congruent. So not only is the midpoint in the middle, but it creates two congruent segments on both sides of it. So we also have these two double slash marks right here. So we have two more congruent sides. Okay, so when we have a mid-segment that I have two midpoints and we connect them, it creates a mid-segment that goes through the midpoints, mid-segment, midpoints. Two things happen. Here's the first one. Two sides of this segment is parallel to the base. And here's the second one that's important that we'll be using. Turn to your neighbor and tell them those last three words.
Side is half as long.
Okay, now say it in your own words. Turn to your neighbor and say those three words in your own words. Rephrase it.
Long as half. Long as half. Tighter. Tight.
Okay? So, face this way. Reveal your face, please.
Sorry,
Are you cold in here?
Yeah, it's cold.
It's never cold in this room. It is 78 degrees in here right now.
Why is your class harder than everyone else? No, you know the French teacher? Oh my gosh, her class is like...
Okay, I would like to continue. So you should have read that the mid-segment is half as long, which means if I rephrase it, I would say DE is half of BC, correct? So I could say if I take BC and cut it in half, I get DE. Write that down, please, because you're going to have to do that on your homework. Notice BC is the whole segment. I multiply the whole by the fraction. Another idea would be take DE and times by 2. That would also work. But I'm going to stick with the fraction idea for right now because later on we have another fraction coming up. So you times the fraction by the whole. Okay, and the very last theorem that we'll be using today. Congruence or concurrency of medians of a triangle. If you remember in class, we constructed a bunch of medians. Median goes through the middle, right? If you have data, you line it up, and the one data in the middle, when they're in order, is the median. You drive down the road, that cement barrier between the two directions of traffic is called the median, because it's in the middle. Notice where the median cuts. It starts on a vertex, goes all the way across to the other side, and then I then get these two dash marks, which means it meets where?
To the D.
What is point D if I get these two dash marks?
It's congruent.
It makes two congruent pieces, which tells me D is what?
Side of the side.
Starts with an M. No, it's what Gerardo was defining for us earlier. Midpoint. So a median extends from a vertex all the way across to a midpoint. Please put the ID cards and whatever those cards are, your plastic key cards, away. There's a time and a place for those, and right now is not it. Now we talked about, we constructed 3 of these, and they all met at a point, a similar point, and there was a word that started with a C for that point. Oh, you're really close. Centroid. There you go. Will you label your picture, please? Centroid. Label your picture, please. Remember that vocabulary word. Medians cross at a common centroid. It's in the center. Centroid. Like a while ago, yeah. Okay. Also, there's a special relationship that happens. If you look at how they cross, is this part A to P, is that congruent to A to D? No. One of them's longer, right? Yeah, this A to P is actually 2/3 the length of the whole. And the shorter part is 1/3 the length. Will you label that on your paper, please? And then turn around, face forward. Pick up your pencil and label, please. The longer section will always be 2/3, and the shorter section will always be 1/3. It's a special relationship that always happens. Carlos Garcia, please label your paper. So, you can take the whole. AD is the whole, meaning the whole segment. Multiply the whole by the fraction, 2/3, and it will tell you the shorter part. Or BF, you can look at the other median going all the way through the triangle from a different vertice. That, again, is the whole segment. If I'm writing this down, maybe you should too. CE is also the whole. I want you to guys get into your heads. If we have a fraction, that tells us this certain piece will be a fraction of the whole. You times the whole by the fraction. Okay, because oftentimes people will they'll mix it up, and they'll times the part by the fraction, which makes the part smaller. That's not what we want. We want to take the whole and make the whole smaller so we can solve for the part. So we always times the whole, which is why I put it here 3 times by the fraction. Okay, we're going to do the first example. These will go in the order of all the theorems we just went through. So the first theorem at the very top of the page. Evelyn, can you read the first theorem at the very top of the page, please?
Yeah.
It's above that shaded gray box.
Okay, so,
Triangle inequality theorem.
yeah, triangle inequality theorem, the sum of the length of any two sides of a triangle is greater than the length of the third side.
Great. So sum, we think what word? Addition. It's the answer to an addition. So it says we can add them, and they will always be longer than the third side. So for instance, we can take 5 plus 8. Is that going to be greater than 6? Yep. Okay, write down, please. There are 3 different combos you have to try out. 5 plus 8 is greater than 6. What's another combo, Cody, I could try out? What's another combo of those numbers in a different order? Same numbers, different order. Give me a different order.
6 plus 5 equals 8.
What number do you want to start with first? 6 plus 8. Is that going to be greater than 5? Yeah. 6 plus 8 is 14. It's definitely greater than 5. And I'm missing one more combo. There's 3 combos in total. Raul?
8 plus...
I think we've already used 8 twice. I don't think you can use that one again.
5 plus 6.
5 plus 6, and that will have to be greater than 8. And 5 plus 6 I know is 11. Is 11 greater than 8? Yes. So the question is, will this actually form a triangle? Since it all works, we can answer yes.
Yes.
Okay, let's do example 2. I need a combination of these 3 numbers to see if it forms a triangle. Okay, Alyssa, can you give me a combination of these 3 numbers? 11 plus 3. Is that going to be greater than 8? Yeah, because 11 plus 3 is 14, right? Brianna, can you give me a different combo of the numbers, please? 3 plus 8. What is 3 plus 8? 11. Ooh, so is 11 going to be greater than 11? Oh, it's equal, so that doesn't work. It has to be greater. And then the last combo we haven't done?
8 plus 3.
We've already done 8 plus 3. 11 plus 8. Is that greater than 3? Yes, but since 1 failed, will these lengths form a triangle? Excellent. So that's the triangle inequality theorem. Does that make sense?
Yeah.
You have a couple like that on your homework. Now for the next one, example 3. Same theorem still. The following two numbers represent two sides of the triangle. Okay, it says list possible values for the third side. I would first actually like us to find what's the shortest side that would make this a triangle.
1.
So think of combos of numbers just like we did up here. Combos of numbers just like we did up here. Find the shortest side that would make it a triangle. Because we've seen one example where it works and one example where it doesn't work. So sometimes it won't work. So find the shortest length of the third side that would make our triangle work. 13 works, but there's one smaller than that. Okay? Once you've decided it, discovered it, put it up on your fingers, up high in the air. Let's see some ideas. I want the smallest value for that blank that would make, using triangle inequality theorem, that would make the triangle work. Okay? There are lots of numbers that work, but I want the smallest one. Because anything bigger than this one will also work. I want the smallest one. I see 1, 2, 3, and 5, and 6. Okay, let's try some of those. Let's try 1. See if it works. 12 plus 1, is that going to be greater than 11?
2 words. 2 words.
But we're on this one right now. Is 12 plus 1 greater than 11? Okay, what about 11 plus 1? Is that going to be greater than 12? Oh, shoot. So 1's too small. Let's try next one, 2. Is 12 plus 2 going to be greater than 11? Yes. Is 12 plus 11 going to be greater than 2? And is 11 plus 2 going to be greater than 12? But wait, what is 11 plus 2? 13. It's true that 13 is greater than 12? Yes. So really our answer is any numbers equal to 2 or greater. Because technically anything larger than 2 works. But 2 is the smallest possible one. Any integer equal to 2 or greater. And mathematically you could show that with 2 is less than or equal to n and go all the way up to infinity. 2 all the way up to infinity would work. Okay?
So it's infinity, like the last number.
Yeah, it's never ending. You never actually reach there. Because there's even infinity to the infinity power, which just means enormous. Very carefully. Okay, number 4. You can when the bell rings. Okay. Shh. We're plowing through this. This is good, guys. There's a problem like every one of these on your homework, which shows you so far your homework's not hard, right? It's not a packet. It's one page, double-sided. Okay. Shh. That's an infinity sign. Sideways 8, infinity sign.
Should I write the?
Okay, don't spin that, please. Okay, example 4. Find the coordinates of the centroid. Centroid. Look on the front of your paper. When did we get the centroid? What's that M word? That when we construct these M words, we get centroids. What is it? Median. So here's a reminder of the median. Everyone take your pencil. Put it up at I. It's going to cross down. What's halfway between 0 and 4? 2. That's the midpoint. So it's going to cross down. Uh-oh. Disappeared.
How is that possible?
Because it doesn't like Word very much. I'm not in the smart software. Okay. Shh.
Who threw that?
Cross down from I, connect to the midpoint. Vertically, I see between I and J, it goes from 0 to 3. What's halfway between 0 and 3? 1/2. So opposite angle is H, cross over. And then the third one we know will cut through that same intersection point. Okay? Now, you can't just eyeball this, because there's going to be error in how we drew it, because we drew it by hand. So to find the actual centroid, mathematically, all you have to do is calculate the average. Okay, so we have averages of x's and we have averages of y's, because each point has an x coordinate and a y coordinate, right? Every point has an x and a y. Okay, Blanca, I have point I right here. Can you tell me what are the coordinates of point I? Blanca, what's the coordinates of I? The x and the y value of that point. No, first we move left and right, 0, and then we go up. 0, that's not 4. 1, 2, 3. 0, 3. There we go. Now we need the points for J. Alejandra, what are the coordinates for J? J is right here. 0, 0. And then we need the coordinates for H. Okay, Parker, what are the coordinates for H? 4, 0. Great. And if you recall, the first number is all the x's. So I'm just going to write a reminder for myself. On the first number are all the x's. And the second number, Luce, what's the name of the second number? There you go. Y's. Z is in three-dimensional graphing. Have we done three-dimensional graphing yet? No. So don't worry about that until calculus. Okay, so I'm just going to label this point P, because that's what was on the centroid on the front side, I believe. So in order to calculate this point P, all we have to do is average them. The x's, add them up, and divide, right? That's how you do average. Danny, can you tell me all of the x values? Great, so we're going to add them up. And then for average, Tristan, what do we divide by for average? 2. But if I have 0, 0, and 4, do I only have 2 numbers there? No, you have 3. I have 3, so I divide by 3. Yep. Okay, Cody, what are all the y values? 3 plus... Great, and again we divide by 3 because there were 3 of them. Now to simplify, let's see, what's 0 plus 0 plus 4? 4, and divide that by 3. Does that come out nicely? So let's just write 4/3. It's the same as 1.3 repeating, or 1 1/3. Okay, and here we have 3 plus 0 plus 0. Hunter, what's 3 plus 0 plus 0? And divide by 3, we get 1. So let's see how we did drawing it by hand. Remember, 4/3 is about 1 1/3. So we come to the right, about 1 1/3, and we go up to 1. See, by hand I was off a little bit, but you can check it visually and make sure you're pretty much in the right space. So the centroid would be at 4/3, 1. Any questions how you find the centroid?
Yes, I get it.
Yes, you get it? Okay.
I don't get how do you know to go from J to the other side of the triangle?
Because that's the definition of what a median is. Okay. 5, number 5. List the sides from smallest to largest. Here's a hint on these ones, 5 through 8. Be careful what the directions ask you for, because sometimes it says smallest to largest, sometimes it says largest to smallest. So make sure you know what's being asked for. Huh?
Would it be like that? Like with the degrees?
Yeah.
Like so 5 would be B, C, D?
Maybe. Okay, so we're asked for sides, but we're given angles, right? So remember this theorem, I did it with my arms. If I start, we're going to start with the smallest. If I have a small angle, what happens to my fingertips? They're going to be close and small, right? So our smallest angle is 34. And notice, I just picked this up on this last period. I just made this connection with the help of a student. He realized, oh, this is angle B. So what are the other two letters that's not the letter B? C and D. And is that completely across from B? Yeah, so that's our smallest one, CD. That's less than, because small, we use less than. Now we find the middle segment. Oops.
Is that one equal to then?
No, they're all going to be less than or greater than when we reverse the order. Okay, now the middle one. The middle is 68, which is angle C. So what are the other two letters, Erica? That's not a C. D and B, right? So that side is clear across. I'm going to put it in alphabetical order, though, BD, which is still smaller than the largest one. Okay, the largest one is 78. Okay, 78 comes from angle D. Hunter, what is opposite of angle D? The CB or BC. Does it really matter which way we put these letters?
No.
No. I usually like to try to do alphabetical order, but technically BC is the same as CB. Okay, for time, I think we're just going to skip down to number 7. Same idea, but we're given sides. We have to tell the angles in order. Perla, will you read the directions very carefully for us? Sorry, number 7. Ooh, which order this time? Largest to smallest. Okay, so we're given sides, we have to look for angles. So we want to find the largest side, and the angle is across from it. Okay, Cody, what's the largest side length? You have the paper in front of you too as well. This is example 7. SQ, because it's 21, right? So that's created by SQ. So what's the only letter we aren't saying when we say SQ? R. So angle R is across from it, which means angle R is the largest. What inequality symbol means largest? Less than? Does that mean largest? No. Greater than. Crocodile, alligator eats the largest, so it should be going that way. You know what? I don't know. Go Google that. Okay, next we have 19 is the middle sized. R to Q. Casey, what would be the angle opposite of RQ?
Angle S.
Great, angle S. And that is greater than the smallest one. So, Tristan, you agree that 18 is the smallest side?
Yeah.
So 18 is on side SR. So what's the only letter I'm not saying besides S and R? Q, because that's across. So it'll be angle Q.
I still get a bit late.
Okay. So if you notice, next one's the smallest to largest. We're not going to do that one because of time, but make sure you read the directions carefully. Let's move on to 9 and 10, because these are the ones where you deal with those fractions. I think I want to do number 10. And by the way, these are given that the blue lines are medians. Your paper will tell you that, but that got left off on here. Okay, number 10. Given, I hope we don't waste time waiting for you because we don't have much left. Given that these are medians, It says find KC. Well, KC is this little segment. What do we know about the little piece below the centroid of a median? It's 1/3 of the total, right? Okay, here's the total. The whole piece is 8x plus 4. Remember I told you, what do we multiply by the whole? We multiply the fraction, right? Sean said 1/3. You multiply the fraction by the whole. Okay? Here's a way to get rid of the fraction. When you solve it, if this really says divide by 3, what's the inverse of dividing by 3? Timesing by 3, both sides. Times by 3, both sides. And we get 9x equals 8x plus 4. Look how easy that becomes. Okay? Carlos Jimenez, how do I get my x's together? How? Which one should I move? 8x. How do I move it? Minus 8x.
From both sides.
From both sides, yep. So we have 1x equals 4. But that's not the answer. It said find KC, but KC is 3 times x. So if x is 4, 3 times 4, KC is 12. And just a reminder on 11 and 12, for finding x, UT is what fraction of the whole? Half. So you take the whole and you multiply it by half. On this one, technically, you can also multiply the short side by 2. That would also work. Okay, and you just solve that for x. Your assignment, which we'll pass out right now, has a similar problem to every one of those we went through. Okay? It's 1 page. Yay, 1 page. It's really not that hard, is it, guys? No, and you have all the theorems on those notes. So please make sure you complete your assignment on time. Your grades are updated too. So go check out your grades. The only thing, actually, I lied. There's one thing that's not on your grade, and that is the Math Excel. Remember a while ago we did an assignment on the computer? I still need to put that on.
No, don't put them on.
Because you didn't do it?
Well, I did the second one. I didn't do the first one. So which one are you putting on?
Both. Okay, if you have my calculator, please bring them back. Please put the lid on and put them in order.